door hardware, doors, frames, and hardware themselves, they account for 1% of a total opening on a project or of a building, excuse me. But that 1% causes a whole lot of problems. And I tell everyone that I interact with about that 1% and how many problems we typically face when helping or trying to understand problems in the field or in plans and specifications. So what we're going to talk about is just the tip of the iceberg, but we're going to help you understand the fundamentals to where we can kind of curve those problems where we don't have them in the future. So like this photo illustrates, we're not going to talk about power door operators, electrified strikes, access security, and things like that. So the first thing in the fundamentals to start us off is handing of an opening. How do we hand an opening in the commercial world? It's a little bit different than in residential. When talking about handing on a commercial opening, you always want to talk about the secure side of the opening, and a lot of people will call that the outside of an opening or of a room. So the fastest or the quickest one that we have here is a right hand or a left hand, and those are very easily identifiable. If you're on the outside of a door and you want to know if it's right hand or left hand, just stick up your hands. This is the easiest way for me to identify the handing of an opening. If the hinges on the opening are on the right hand side and it swings away from you, that door is a right hand swing door. And if it's hinged on the left and it opens away towards the left with your left hand, then it's a left hand swinging door. Now, alternatively, if it's hinged on the right or the left and it swings to you, it is going to be a reverse bevel or right hand reverse, left hand reverse. You do have some special situations, as you see on the bottom of the screen here, where you have a double egress pair. The outside of that opening is actually going to be on the pull side of each side, and so this is going to be a left-hand reverse by left-hand reverse pair of doors. But the way that they have this situated, you always want to follow the flow of traffic. So you're walking, just like when you're driving, you're walking on the right-hand side of a corridor. As you walk through that corridor, you push yourself away towards the right, and you go through that opening. Right hand going through this way and right hand going through this way. But on the outside of that opening or the secure side, those are left-hand reverse by left-hand reverse. Another fundamental, one of the most basic fundamentals, is finishes of product. Finishes, as you can see in this illustration, are defined in two different ways. One is either federal specifications, which is ANSI or American National Standards Institute, or the BHMA. The most commonly used today are BHMA and ANSI, and you can see those here with some really quick ones. The most identifiable one being 626, which is US 26D. I think it's pretty far down on the list here, and that is satin chromium plated. That is one of the most common finishes in our market. ANSI and BHMA, when identifying their numbers, they use the base metal and then the finish coat of the metal to identify what that finish is whenever presenting that or identifying that to its customers and end users. They created a national standard so that way whenever architects, end users, contractors, or distributors, when they identify a product to you, they don't say, oh, is that is that rust or is that black prime? They can identify that and they can say, okay, this is 613 or US 10B. So that way they can say, this is what that color is. We can identify that. We can send that on to the manufacturer, and that manufacturer knows what color you're looking for. Now, residential and lower grade or lower tiered products, they do sometimes will say this is a satin chrome, but then they'll just use the identifier as satin chrome. Watch out for that whenever trying to identify that for your customers. So here's some more on ANSI, which is a quick reference to ANSI and BHMA. All ANSI numbers begin with A156. And so when identifying either finishes or products, you'll use an ANSI number. ANSI A156.1, for example, is cylindrical locks. 156.13 is mortise locks. And then 156.18, I believe that's exit devices. And then it goes on for quite a while. So ANSI standards, they set forth and they created a grading system of hardware, whether it be grade 1, grade 2, or grade 3. Grade 1 is identified by the cycle usage and also the pound of pressure that that product can take. I believe grade 1 is at 800,000 revolutions and 350 pounds of force. Grade 2, I believe, is at 500,000, and grade 3 is 250,000 cycles. So if you have a building where you have 100 people walking through that opening 3 times a day, you're going to look at about 300 uses of that lock set per day. And so if it's light use such as that lock set will last you somewhere in the range of 40 years, I believe. But if you have 1,000 people, say in a school or something along those lines, and that building is used for class 5 times a day, you're going to have 5,000 uses per day, or 25,000 uses per week, I believe, and it can rack up pretty fast on how long that opening can be used prior to wear and tear, breakdown, and those sorts of things. There are some manufacturers out there that whenever you're talking usage, Allegiant, I'm just going to say broad manufacturers, Allegiant has a lock set, a cylindrical lock set, that I believe they're at about 5 million cycles. You have another one from Sargent that is about 3 million cycles. And then you have one from Best Manufacturing or Dormakava that can go upward of 20 million cycles. So depending on what you're looking for, just because a product is grade 1 doesn't mean that it's superior to another. You might want to check what their cycle test is before or prior to breakdown, and what your usage is going to be when identifying what product you need for your building. One of the fundamentals of door hardware that is most of the time overlooked and underestimated is keying. Keying of either existing buildings that have an existing key system or an existing building that has a new key system. Keying can sometimes become very intimidating, but if you connect with a professional or with a company that houses professionals, keying is an essential part of any building. Don't rely on just a local locksmith or something like that. And mind you, locksmiths are great and they do a great job at what they do. But what I'm saying is when you're trying to key new product to an existing key system or new product for a new key system, help use professionals and do it at the manufacturer, so that way it saves you time, money, and a lot of headache. So understanding keying in an existing system, there's some things that you have to know when trying to utilize that system. One is who's the manufacturer originally. So a lot of times you'll see where an old building is keyed and one manufacturer's keying because they have locks from that manufacturer, and then the new building is trying to match what they're doing, but you're trying to match 2 different manufacturers, 2 different key systems, 2 different keyways. And so you have to understand that each key, each bow is different for every single manufacturer. There are keys that are out there that are very commonly used, and every manufacturer has access to those keys. but just like anything else, a lot of manufacturers, or nearly all manufacturers, will have a proprietary keyway that they want to put into their buildings, and make sure that you understand what you're doing prior to trying to put new keys into that system. So you also want to know, is that key system conventional core or is it interchangeable core? Conventional core is going to be a key in knob lever that is not able to be removed. It usually looks just like a standard circle with a key bow that goes through it. And if it's interchangeable core, it's going to look like a snowman or a figure eight. It's going to have one circle at the top, one circle at the bottom. One of the most common interchangeable cores is a small format interchangeable core. Dormicaba or Best, they are the ones that invented that. But over time, patents expired and things like that. There are now full-size interchangeable cores. There are also duplicated or mimicked small format interchangeable cores. You'll want to know in your existing system, is the factory going to key the new locks? Is the owner going to take care of the keying themselves, with their key shop and in-house if they're at a university or a hospital or a government building? Or are they going to have a local locksmith that's worked with that end user in the past? Are they going to key the product? Make sure that you identify that, because that's a major issue, especially during the building process. Here it says construction keying is always a good idea. Absolutely, it's a good idea. There are some manufacturers that have very special construction type keying that goes in with their permanent cores, that you can have a in construction key that you use, and as soon as the building is completed, the owner will take their permanent key, put it into that cylinder. As soon as they turn it, the key has now changed the configuration of how that lock is configured, and construction key no longer works. That's very special, but there are some basics, and one of the most basic things is just use construction keying, whether it be a plastic core or a green construction core or any other type of interchangeable core. It's simpler. If we had a new key system, construction keying is key, because you want to make sure that the building owner, the contractor, is able to secure their building and make sure that they don't have any type of theft, anybody in there after hours. They want to be able to control that space. You want to find out, is the keying patented or restricted? This is going to be some special types of keying where you have a patent on the keyway. This is what we discussed in some of the previous slides. If that keying is going to be protected, whether it be for 10, 20, 30 years, or if it's restricted, where no one else can get that key, you have to keep in mind, if they're patented, if they're restricted, you will have to really think about locksmith's access and also local access to that keyway if you have a problem, if you need the building rekeyed or something along those lines. Because once it's restricted, you're going to have a hard time unless you have a letter of authorization and that sort of thing to get that facility rekeyed. You'll want to make sure that you can control that keying. You'll want to do it with a key control box. This is usually located in the manager's office or principal's office, the building owner's office. And what this is every single key that is made for every single lock in that facility is tagged and marked. And most of the time it is situated in that key box to where there's some control and there's some kind of configuration to where they can identify those keys really quickly. It's usually that way, but sometimes it's not that way. Sometimes people will just take the big old bag of keys that they get from the manufacturer or the contractor. They'll just dump it in that box or dump it in their drawer and figure it out whenever you have some lost keys or someone quits or someone gets fired, something along those lines. You'll want to then also think about key control software. Every manufacturer that's out there will have some sort of key control software, but you want to be able to use some sort of key control software. So that way, if you do have an in-house locksmith, or an out-of-town locksmith or a local locksmith, you'll want to be able to send them your key records so that way they know how your building is keyed and they can help quickly identify and also register openings to that software to where they can build your stuff out or replace your stuff really quickly. So whenever you're scheduling hardware, and this is going to be for specifiers only, but it's also very important for anybody that uses hardware to know these. DHI came out with this specification schedule a long time ago, and it's very useful. And those are what we talked about at the beginning of this whole presentation. That's hang the door, secure the door, control the door, protect the door, and seal the door. Hanging the door can be the most simple thing. It might be used with conventional hinges, such as butt hinges, and those are going to be your standard leaf hinges that move just like so, 3.5 inch, 4.5 inch. They're very common. You see them at your house. They're the 3 hinges that are up and down your door, but you have to have some sort of pivot point at your opening in order to have that door freely swing inside your door frame. But they don't have to be conventional hinges. They can be continuous hinges, and that is most commonly referred to as a piano hinge. And that is a hinge that goes from the very top of the door to the very bottom of the door. And it allows the pivot point to be across the entire leaf of the door, and it also allows weight distribution to go from the top of the door to the bottom of the door. When you're using conventional hinges, the load of the hinge is primarily at the very top of the door, and what that does is it creates a lot of wear and tear, not only at the door and whatever's connecting that door, whether it be hollow metal, aluminum, or wood, but it also puts a lot of load at the hollow metal frame or the wood frame, and that reinforcement that holds that together. So you want to, if you have a door that is heavy, such as a lead line door, maybe a 5-foot leaf that's hollow metal, that's 10 foot tall, you might want to think about using a continuous hinge or even pivots. Pivots allow you to put the load at the very bottom of the door. So it puts the load in the floor instead of on the top of the door, on the reinforcements of the door and the frame. And it allows a person, especially in a situation where a building settles or there's a lot of weight on an opening, it gives you an aesthetically pleasing hinge or pivot point that can be concealed and things like that, and is also going to be able to take the weight. You're also going to have, in some situations, such as aluminum doors or even some lead line doors, where you're going to have a floor concealed door closer. And this is going to be where you have your pivot point at the floor, weights being distributed through the ground, through the building, and you're able to control the door all in one hinge. Now, this does take a lot of extra work, whether it be planning whenever they are pouring concrete, or planning post concrete, which I hope you're not trying to put in concealed closers post concrete, but there's a lot of planning involved. You have to know exactly where your openings are going to be. You have to know exactly where your pivot's going to be. You have to make sure that your frame is going to be true and square, because if not, you're going to have a lot of problems in the field. Here's some examples of some conventional hinges. We'll have heavyweight, which is going to be 0.180 thickness, or 3/16 of an inch. You'll have standard weight hinges, which will vary from a little under 1/8 of an inch to 1/8 of an inch thick. And then you'll have spring hinges. Spring hinges are going to be a very cool situation where you can control a door and also use your pivot point at the hinge, and you won't have to go with a closer or anything like that in the future. Spring hinges are ideal for apartments. where they have to be 20-minute rated, and that the front door of that opening has to always close. We'll get into fire rated openings a little bit later. But they can also be used at exterior uses, such as gates or doors at exterior uses, especially not highly rated, or doors that don't need to meet ADA, places like that. Spring hinges are a very good application and a very economical application. So with conventional hinges, you do have a little bit of leeway for what they look like, not in the body of it, but at the top of it. And some very common tips that they use are button top or button tip. And that is just going to be your flat, smooth top. A hospital tip, if you have an area that needs to be managed to where you don't want any type of ligature points or anything like that, you'll use a hospital tip. You'll also want to use them in hospitals where you need to clean those hinges to make sure that bacteria and things like that aren't going behind those hinges or that pivot point. And then in churches, and just like the name suggests, a steeple tip. These are primarily a decorative piece that are used in churches or something such as a church to give it a little bit more decorative look than just your button tip or your hospital tip. So with all of those in mind, you can put a non-removable pin or NRP pin, and what that NRP does is it does not allow the pin, once the door is in place, it does not allow the pin to be removed. Once that pin is removed, if you open the door, you can then move that door out of the frame and leave the one leaf of that hinge on the frame, one leaf on the door, and it helps with, or some would say that it helps with the install process. There are some special applications. Most of these are going to be for areas such as exteriors or hospitals, but what these will do is allow you to either swing clear of an opening if you need a full 36-inch opening due to ADA requirements and things like that in a hospital, for example. A raised barrel hinge. So if you have a door jamb that has casing on it or something along those lines, you'll use a raised barrel hinge, and what that does is it raises the barrel to allow that frame or the jamb to put, you could put casing and things like that at that opening, to where it doesn't interfere with the pivot point and it doesn't interfere with the door whenever it's trying to open. You'll also see wide throw hinges, and what that does is just like the name suggests, it throws the door in a wider, I guess it throws the door wider to allow it to clear the same thing, casing. If you have something on the door, that would prevent it from being able to open it at the jamb more than 90 degrees. But then you also might have reinforced hinges. A reinforced hinge is going to allow you to distribute that weight a little bit more at the top, instead of having that just the pivot point of the standard butt hinge on the style of the door. This will go at the top of the door and on the style to allow you to distribute that weight all along the top of the door instead of just at one small space. When looking at continuous hinges, you're going to have a couple different types. They'll either call them pin and barrel, mostly seen on stainless steel hinges, or aluminum geared hinges. So a pin and barrel hinge is just like a butt hinge, except it extends the full length of the door, but it has a pin that goes through the continuous hinge, and the barrels, where the bearings and things like that, or where the pivots actually hang on the or connect together to hang on that pin, how they're all situated to where that continuous hinge will work. Aluminum geared hinges are a little bit different. They use gears to connect to each other. So instead of having all the bearings and the separate spots of the pin and barrel, the gear hinge is going to distribute that weight and allow that pivot point to work just like a gear would to help with that weight distribution. Pivots. Pivots, like I said earlier, are for openings that are going to have heavy weight, but they can also be used in special applications such as double acting doors. A butt hinge can only open and close, but it can't double act without some sort of special barrel to allow that to happen. And we can talk about that here in just a second. I believe there's a slide that will show a double acting butt hinge, such as one from Bomber or companies of the like, or even Stanley. But a double acting pivot is one of the most common applications that you'll see. And what this is if you have rescue hardware or in a patient room where you want to allow access both into the room and out of the room. If, say, a patient gets stuck in an opening or something along those lines, you'll use a special type of frame called a cased opening with rescue hardware applied at that lock side of the door to where it will create a stop, so that way you can use it in normal application, and also you'll be able to remove that stop to where you can open the door if someone is stuck inside the room. But pivots, they're not only used to distribute weight, they're also used in special applications. So a 3/4 inch offset pivot is going to be your most common, and that's if you have a standard door and a standard frame. You want it to open just like a continuous hinge would open a door, or you want it to open just like a butt hinge would open a door. This would be the most commonly used one. But an 1.5-inch offset pivot is something a little bit different. What it does is it offsets the pivot. So once the door is closed, it looks just like a normal hinge would look. But whenever the door opens or opens, what it does is it's offset 1.5 inches. So if you have some type of special paneling on the door, say you have some sort of casing that's applied to the face of the door. If you open the door, standard, it might hit the frame or it might hit the wall, something along those lines, and it won't allow the door to open a full 180 degrees. So you'll use a 1.5-inch offset pivot to where it will swing out enough to where it will open fully, so that way you can access that room. Floor closers. Check out the body of the floor closer that you see down at the bottom here. As you can see, if you're not planning this thing out, this is a massive hole that you have to be able to chip away at, reinforce, and then install, and then more than likely remortar in, so that way it will operate correctly. But offset pivots, they give you the closer body in the floor. They allow for you to have that pivot. They allow for immense weight, and they allow for great operation of the opening. This is going to be typically seen in aluminum storefront openings, where you have the old Dorma floor closer, or even another manufacturer would be Rixson. But this will either allow you to have it offset 3/4 inch, offset 1.5 inches, or even center hung, to where if you wanted to use this at an aluminum storefront door, you can use a center hung pivot. It gives you a center hung pivot point where that door operates, and things like that. But they don't only have to be that deep cutout. You can also use offset shallow depth floor closers to create that same application. They're a little bit different. There's uses for both, but just check with what you're trying to do, or contact a professional to identify what you need for your opening. A lot of aluminum storefront manufacturers and distributors have started to move more towards continuous hinges, ease of installation. You don't have to go through that planning, and it's a little bit more easy for an end user when trying to fix one after 20 years of use, 30 years of use, 10 years of use, or even 5 years of use sometimes. So just make sure that you identify that prior to building your building. Do you guys have questions? Now we're going to talk about securing the door. The first thing to talk about when securing a door is the inactive leaf. People always get jumbled up when thinking of inactive leaves of openings, and you have to think of an inactive leaf just like you're thinking about a door frame at a single leaf. You need to be able to secure it to where it's solid, and you have to be able to have the ability to latch to it. So you're going to need some sort of strike. You're going to need to be able to latch it via flush bolts, whether they're manual flush bolts or automatic flush bolts, or even self-latching flush bolts. At the inactive leaf of doors, you'll sometimes find a vertical rod, a surface concealed, a surface or concealed vertical rod that will secure that inactive leaf. And there are some special situations where you have a vertical rod by a mortise exit device, or you have two vertical rods, two concealed vertical rods. These are all going to be at the inactive leaf. And then you have to have a way to control when the inactive leaf is closing in the door, because like I said, you have to treat the active leaf just like it's going into a single frame or a single opening. So you want the inactive leaf to be latched and closed properly first prior to the active leaf going into it. And to do that, you need a coordinator. I'll show you what a coordinator looks like in just 1 second. So some of the typical hardware that you'll find at an inactive door are going to be flush bolts. And what you see here are different types of bolts. The first one is just a sliding bolt. You'll find this most commonly at pump rooms or maintenance rooms, and you can only put these in at non-rated inactive leaves of doors. If a customer or an owner wants to put this in after you have your certificate of occupancy and after the fire marshal has come through and approved the opening, the following year, whenever their building is inspected, they'll have to be removing that device. But it is very useful because it's surface applied. It's able to secure the inactive leaf, and it prevents someone from getting in from the opposite side. Manual flush bolts are usually put in prior to or during fabrication of that opening. You can't put it in afterwards like you can a slide bolt, but a manual flush bolt is only used at non-rated openings. And what it does is there's a little lever at the bottom. It's supposed to be 5 to 10 pounds of pressure to meet ADA, but you basically will pull that down and it shoots a bolt up into the frame. If you have one at the bottom of the door, then it'll shoot down into the floor. So it creates two latching points at the inactive leaf to where it's the leaf is secured at the top and bottom. Now, if you have a fire rated opening, whether it be 20-minute rated, 60-minute rated, 45-minute rated, or 90-minute rated, you're going to have to use a type of automatic flush bolt or self-latching flush bolt. And what this does is when the door, the inactive leaf closes and the active leaf closes into it, basically the top and the bottom, you can see small little latches there. The door will slide over those latches and shoot up the latch into the frame and into the floor. Now, there are constant latching flush bolts that will latch every single time that you close the inactive leaf. You'll then have to depress a button to where it will open up. But these are some examples of those. You then have vertical rod exit devices, whether it be concealed or surface applied. These work just like a flush bolt will, where they will shoot up into the the head of the frame and also into the floor. And whenever you press on the exit device to leave, you're able to retract those bolts, open the door, and then once it closes back, it will then shoot up again. Here's an example of a coordinator. What a coordinator does is as the inactive leaf closes into the door, it will be held open, or the active leaf, excuse me, the active leaf will be held open to 5 to 10 degrees until the inactive leaf has a chance to close completely into the opening. And then it will depress a button. You see it on the left-hand side. It'll depress a button. The active leaf will then be able to close into the opening. This is used whenever you have a cylindrical lock, mortise exit device, mortise lock. It will not be used whenever you have vertical rods or concealed vertical rod, as those openings aren't interacting with each other. They are independent of each other. So you're able to depress the rim device or the push pad on the device to where you can operate those doors. Another big reason to have this the inactive leaf closing first is if you have an overlapping astragal at a fire rated opening, that flat bar astragal needs to be closed because it cannot, flat bar cannot go over a door to be able to close itself. So fire rated openings, there's a big rule. They have to be self-latching and self-closing to be able to meet fire rating. And so if that inactive leaf is not able to latch, it no longer meets its rating. So coordinators are pivotal in those spaces. You'll also see a carryover bar, which is on your left-hand side there. And what that does is it acts just like a coordinator. It's installed on the door, however, instead of the frame like the coordinator is. So securing the door, well, some of the major things to secure a door are lock sets. Cylindrical locks. The name is very easy to figure out why they're called cylindrical locks. It's because they use a cylinder to be able to connect the two pieces together. There's different grades of cylindrical locks, whether it be grade 1, and we talked about that earlier. Based on the cycle test, they are given grade 1, grade 2, and this isn't mentioned here, but also grade 3. Grade 3 is going to be very, very economical line of hardware. A lot of people will use these at apartments and places like that, but be mindful if you're in an industrial setting or in a commercial space, such as a school or office building that's going to have high use, high traffic, conference rooms, break rooms, bathrooms. You're not going to want to use a grade 3 lock. You'll want to either go to grade 2 or grade 1. One of the major differences between the two is grade 1. You'll most oftentimes find that the chassis inside of it is not cast metal; it's stainless steel. But then you also have mortise locks. I have an example of a mortise lock, and it's right here. So a mortise lock, just like the name is defined, at the edge of the door, it's mortised into the edge, and what it does is it's a whole lot more secure. It's a whole lot more tried and true, I guess, than a cylindrical lock. It will last a whole lot longer, but more expensive. More metal, more expense. And then you'll have deadlocks. Deadlocks have a great place. If you are, again, in an apartment complex, in a restroom, deadlocks will allow you to take an opening that has a passage lever or passage set and be able to secure that opening. If you're in a restroom, based on your local jurisdiction, you might want to check and see if it needs an occupancy indicator on the opposite side prior to just arbitrarily installing that. But if not, deadlocks will allow you to secure your space. Deadlocks come in both cylindrical application and also a mortise-in application. So let's talk about cylindrical locks a little bit. We have an example here of a cylindrical lock, and as you can see here, at the edge of the door, you have a latch This is the piece of the material that's going to be latching into the door frame itself, and it's interconnected to the cylindrical lock via the chassis, and it's able to interconnect. Whenever you install that piece of material, you install it from the face, one side of the face with the through bolts, and then the other side of the face with non-through bolts. You install those together, they interconnect with the latch, they give you the ability to operate that opening. The latches can come in various depths. The most common in our industry is 2 3/4 of an inch, but in residential or in light use commercial, you'll see 2 3/8 of an inch back set. And also you might see in special applications where you have maybe a very heavy duty sound door. One manufacturer that comes to mind is Krieger, where they have an extra panel onto the face of the existing panel. By doing that, you have to have some sort of special casing, the gasket and things like that. And because of that, you have to have an extra deep latch. Could be 5 inches, could be 3 3/4 of an inch. Just depends on what door you're using. But if you have something like that, make sure that you consult with an expert, so that way they can get you the proper latch. But there are various latches that are out there to help you. Looking at cylindrical lock trim, you're limited with some manufacturers on the design of those levers, and you're also limited on your functions. We'll look at some of the most common designs that are out there. Just your standard return, that's ADA approved. A curved lever is also ADA approved, and then your straight lever. There are some special applications out there where you have some manufacturers that provide some different types of roses and different types of levers to where they're more aesthetically pleasing for your building. You just need to check with the manufacturer that you're using to see what you're trying to accomplish and see if they can help you. One of the major differences from a cylindrical lock to a mortise lock is the capabilities are so much more great. So with a mortise lock, unlike a cylindrical lock, you can add a deadlock feature. So a cylindrical lock, you'd have to have a deadlock at the top, which is a separate piece of hardware, and then a lock at the bottom. By doing that, it does not meet ADA. But with a mortise lock, you can add that same deadlock. You can have your latch, and it also meets ADA. How is a mortise lock put together? When putting it into the opening, you take your standard lock set here. Make sure that your cylinder is at the top. The cylinder is a 1 1/4 inch piece of hardware, or 1 1/4 inch cutout. It slides into the door. Once it slides into the door, you'll want to then be able to install something that looks like this. And what this does is this allows your lever to operate completely on the on the door. There's a spring inside here. I don't know if you can see that, but there's a spring inside here, and so it will, once the lever is depressed, it'll pop it back up. Different manufacturers have a different look to their little case here, but then you take the lever and the rose, you slide it through the door or through your mortise lock here and through the door, and then it allows it to operate just like so. So depending on what type of mortise lock that you have, you'll have various functions, and we'll talk about those in just a second. But with a mortise lock, you have a lot more capabilities of designs. You can either use the standard designs that come from the manufacturer. You can use decorative designs that come from the manufacturer, or you can even use custom levers that the manufacturer either purchases from another manufacturer, or you can purchase your own from another manufacturer to give you that aesthetically pleasing application that you want. Like I was saying earlier, there's a lot of various functions that are out there with these lock sets. You can either go single keyed, double keyed, non-keyed, or keyed with or without a deadbolt. And so you're going to see passage, privacy, storeroom, classroom, dormitory. But you can also see some special applications such as a privacy with an occupancy indicator on the opposite side. And what that will be is it will allow a customer or an end user at a school to throw a thumb turn, and it will tell persons on the opposite side, hey, this room is occupied, you cannot come in. You cannot do that with a cylindrical lock. You'll have to use a separate deadlock to be able to do that. So keep those things in mind. Deadlocks, they have their application. You can use a tubular or cylindrical deadlock, a mortise deadlock, but let's go back. But they work just like a mortise lock to a point. They are the deadlocking portion of a mortise lock. So if you are at a non-rated opening and you wanted a deadlock, or you can either use a cylindrical or a mortise deadlock, and you can give yourself the ability to have that deadlock, have that visual indicator piece, to where you can have some different applications. So you're not only able to secure your opening with cylindrical locks, mortise locks, or deadlocks. There are also some special applications out there. If you're at a gate and you need a padlock, if you're in your office and your cabinets need to be locked, or if you have your key control box that we discussed at the first of the class, and you want to be able to lock that room up. And there are also some miscellaneous locks out there to be able to do that. So securing the door, we talked about lock sets, and then we also talked about earlier some exit devices. These are some examples of some of the exit devices that are out there, whether they be mortise exit devices, rim exit devices, or concealed or surface vertical rods. A rim exit device is one of the most common devices that you're going to see at exteriors. You're also going to see surface vertical rods and concealed vertical rods. You're hardly ever going to see the crossbar anymore because they no longer meet certain codes and standards that are in our industry. They have the ability to allow a person to chain the opening down, and that does not meet life safety or NFPA. So this little fire guy here, he shows you that these are rateable, fire rated, but I would strongly recommend against the crossbar rim exit device. So if you have a pair of doors that you want to independently operate, we talked about this earlier, you'll use a surface or a concealed vertical rod, or you can even use a rim exit device, but you have to use something special with it. And we're also going to talk about another application, but surface and concealed vertical rods, they're independently operable, which gives a customer the full width, whether it be an 8-foot opening, a 6-foot opening, or something along those lines, but they're able to use those devices to where they can open the whole building up, and they can even open them up and hold them open with electromagnets or something along those lines. Rim exit devices, they also have a place, but you have to use something special in the middle, and that's called a mullion. That mullion acts just like a hollow metal frame, and it allows that rim exit device to surface, apply itself, so that way it can be operable. Now, there is some special hardware that you can use a rim exit device on an active leaf, but you cannot activate the inactive leaf, and that's basically, it's a flat bar strike, and it's about 2 inches long and about 2 inches high. And what it does is it will protrude out of the opening, and it will allow that rim strike to basically catch onto it. Now, it does not, it's a hanging feature, and so it's not recommended, but if you have a customer that has to have it, there is an application that suits it. But there's one that's better than that. And if you have an inactive leaf, where you want to be able to have one of them or both of them independently active, this is going to be a special situation where you have to have a coordinator. But this shows a vertical rod by a mortise rod exit device, or mortise exit device, excuse me. I would recommend more is standard and active leaf, where you have flush bolts, automatic flush bolts, a coordinator, and then a mortise exit device. It is more practical, more economical, but you can use a vertical rod exit device, a mortise exit device. They can work independently, but with a coordinator, they'll also operate independently. Do you guys have any questions? So the next step is going to be really quick. I'm sorry that I overshot the presentation a little bit, but controlling the door is going to be our next one, controlling and protecting. These are going to be really quick. So just to go over it really fast, controlling the door, you do that with a door closer. And door closers come in various arms. The first one of the most common, is a regular arm exit device, or excuse me, closer. And what a regular arm closer is it's a closer that's installed on the pull side of an opening. The arm bracket itself, and I'll show you one. This is going to be the only time I'm going to show you something that's branded, so I apologize, because this is an AIA class, but it's an example that I had. This is a regular arm closer. At the frame, this little shoe here is installed at the head of the frame, at the face of the head of the frame, and then the body itself is installed on the pull side of the opening. And when you pull the door open, it will allow the closer to operate. The next type is a parallel arm. Parallel arm closers are installed on the push side. So something that I always use is, if you are on the push side of a door, you want to use a P style closer, which is a parallel arm. So you might keep that in mind for future use. Now, if you want to install a regular arm on the push side of an opening, let's say it's for an exterior use or something like that, and due to limitations, you didn't have a parallel arm, or you didn't have a blade stop reinforcement, or the frame just would not allow it, you can install a closer flipped to where the closer itself, the body is installed at the face of the frame, and the arm is installed at the on the door. This will allow you that ability to install the closer at the push side, and it'll operate just the same. You might want to make sure that you have proper reinforcements and things like that, but it is possible. And the last one is going to be a track arm. Track arms are only installed on the push side of the opening. They're not able to be top jam mounted or anything like that, but they do give a little bit more aesthetically pleasing look, because a track arm does not allow the opening or the arm to be out into the room. So if you have a situation where you're dealing with high school kids or something along those lines, and they're grabbing on the top. Yep. But they're grabbing on the top of the opening, a track arm will remove that. So we talked about all of this earlier in the previous slide, so I'm just going to show you what the application looks like and then move forward. But this is a regular arm, and it does show how it's installed. As you can see, the shoe bracket is installed at the face of the frame. The closer itself is installed at the door. On a parallel arm, it's a little bit different. On the stop, underneath the head of the frame at the stop, a parallel arm shoe is installed into the head, and the arm itself runs parallel to the door. It's on the push side, and it operates as such. Top jam, just like I showed you, if you have a frame where you want to mount the closer at the head and the arm at the door, you have the ability. If you're at like an exterior application, it's one of the only applications that I know of that you would use it for, but this is where you'd see it. Or if you have very low clearance at a wall, so say the wall is tight and you have no room for that closer, if you open the door and it hits and it doesn't allow you a full 90 degrees, you might also think about a top jam closer. Track arms, as you can see, These guys are so aesthetically pleasing. The closer arm itself just runs right on that track. You have the ability with the closer to control it a little bit more. You can put different types of applications such as stops or hold open, depending on what the rating is of the door. But there's so much more that you can do with a track arm, and it gives you a great look. So taking a look at this quick photo, I thought about this photo quite a bit, and it is wrong how they installed it, but I think they did it with some good intentions in mind. So this opening, you can tell that they installed the closer arm on the opposite wall, and then they installed the closer at the pull side of the door. But if you really look at this closer, the way that it operates and things like that, once you open the door, the closer is going to start to operate, and it gives you, and this is a very expensive way to do this, but it gives you a stop, right, or a hold open, excuse me. So this door is going to open, and it's going to hold itself open until you pull it closed. So there must be some sort of special application that was going on in this room, but it's very strange that they wanted a hold open device and they used a closer to do it. If you're at a fire rated opening and you want to be able to hold your door open, you can electronically hold open your door either by using a fire check style closer, which they don't even show here, but they are there. Oh, there it is at the bottom. So the closer itself can open, and it's electromagnetically controlled. In the event of a fire, it will send a signal. It will release the magnet that's inside the closer arm, close the door to where it will close the door during a fire. You can also use an electromagnet that's installed at the wall. These are either surface applied or recessed. And what this does is, as you open the door, if you have a wood door, or a magnetic door, like a metal door, you can open the door, it will close up against it, and in the event of a fire, it'll do the exact same thing. This, to me, is a lot cheaper door stop than what you saw before. This one, by throwing that broom in there, you can quickly operate that stairwell to where you can take trash and things like that through there. But this, the broom is not rated for fire or life safety. So keep that in mind. If you're scheduling brooms at stairwells, you might have a problem with your AHJ. So controlling the door, we talked about floor closers earlier. This is one little example that I'm going to show you. But the main thing that I wanted you to take away from this, because we've already discussed recessed floor closers, door closers, they also can be installed into the frame. So if you have metal doors, aluminum doors, or even wood frames, these can be installed up into the frame, allow you that control, and give you a little bit more aesthetically pleasing look at your door, rather than, say you're an architect that doesn't like a lot of jumbled mess on a door, a closer, and an arm or something like that. You can use a track arm, and then you can install it into the frame. It's more aesthetically pleasing, it's easier to control, and it might help out your application. Or if you have panels, or if you have anything at the top of the door that you don't want conflicting with a closer, install a concealed one. These are also going to be used in schools. The same process. If you have kids that are hanging on the closer arms, installing a concealed closer will allow you to get rid of that problem. If you're in a hospital, in a mental health ward, something like that, and you want to control that door, this is also going to be the right application for you. So protecting the door. These are going to be the most quick portion of what we're going to be discussing today. But there are various different ways to protect the door. And basically what you want to do, I'm not going to show you each example here, but kick plates, armor guards, edge guards, and then mortise latch guards. the basic intent of all of these is to protect your door and allow you to have longevity of your opening. This is going to save you money in the long run. It's going to save your customer headaches in the long run, and it's just going to protect your door overall. Because as we all know, as people work in buildings, they're going to push carts in, they're going to push their trash cans through, push their brooms through, they're going to slam things, break things. This will help protect you against that. But also push and pull devices. I'll ask you guys about some different unique situations that we have later on, but push and pull devices in restrooms, conference rooms, break rooms, places like that. This will help protect the edge of your door from, bacteria, germs, grease, oil, things like that. So having a push or a pull, this will allow you to help protect your door against that. And then door stops. If you don't want to use that broom that we saw earlier, you can either use a friction stop on a door closer, or you can use floor or wall stops that are going to be mounted on the opposite side of the frame. And this will protect your walls, it will protect your hardware, it will protect your overall building from getting damaged just with a $5 pull or stop, excuse me. They can be installed on the wall, the floor, and like we said. So the last slide, and again, I'm so sorry for going 15 minutes over, but sealing the door, while we only have one slide to talk about it, and maybe it's because the people that created the program, they don't really get into the sealing of the opening, but it's so important. You want to be able to keep weather, wind, debris, animals, and pests out of your opening, and you have to be able to do that somehow. And the way that we do it is by using kick plates, or thresholds, and automatic door bottoms, surface door bottoms, gasketing, whether it be surface applied, such as your bubble gasketing at the bottom, or it's screw applied. You want to be able to weatherize your opening to where you protect your building and protect not only what's inside, but also what's outside. You don't want to lose energy because you're not properly sealing your building. So make sure that you use proper gasketing. If you have a fire rated opening, you're going to need some sort of bubble gasketing or some sort of weather stripping at the floor, at the sides. Make sure that you're using that. And if you don't know what to use, consult a professional and they can help you out. That concludes what we were discussing.